What's up everybody, and welcome to part 2 of my naive Bayes classifier from scratch series. And in the previous video I gave a short recap of how the naive Bayes algorithm works, and we have already made all the preparations in our notebook. So we made the import statements, we loaded our data, and then we started off with the first step of the algorithm, where we want to create such a table here, which is a nested dictionary. And then we also created the skeleton of the table. So now we want to create the actual logic. We have this create the skeleton of this function here. And now we want to create the logic for this function. Therefore, let's first create some variables called df and label column, so that we have something to work with. So we're going to say df equals df train and label column equals survived, because that's the label of our data. Okay, so let's run this. Now let's start to write the code for this function. So the first thing that we're going to do is to initiate this table here as an empty dictionary, and that table then we want to populate within the function. So we're going to say table equals an empty dictionary. And now the first thing that we're going to do is we're going to determine the values here for the feature. So we're going to say, I'll create a comment. So we're going to say determine values for the label. So we need to determine the class names and class counts. So therefore, obviously, we first need to access the label column. So we're going to say df brackets label column. So this way then we get the label column. And now we want to know what the unique values of this column are and how many counts we have for each value. And therefore we can use the value counts method. So we can say value counts and then run this. And here then we get the result that there are 549 survivors, which we also see here. Whoops. 549 and 342 survivors. So now, before we actually store those values here in our table, I would like to point out some behavior of this value counts method. Namely, what it does is it lists the value first that appears most often. So in this case, we had more survivors. That's why the 0 is here at the front. However, if there would be more survivors, so we had more non-survivors. So if there are more survivors, then this would actually be listed here in this first place. And where we can see that is if we, for example, only look at female passengers. So let's filter our data frame. So we're going to say df brackets where df.sex equals female. So we're only looking at the female passengers. And here there are actually more survivors. That's why this one here is listed first. But obviously this is a problem for our table here. Namely, the order of those elements here matters. So, which we have discussed in the previous video. So what we want to do is we don't just want to store those values here based on which class appears most often, but we need to store those values in a particular order, so that then the respective probabilities that we determine then refer to the correct class. And we're going to store this thing here, or the order that we're going to use is simply we're going to order here the index numerically. Or if the index would be strings, then we simply would do it alphabetically, and therefore we can use the sort index method. So we can say sort index, and this now sorts the index. So now the 0 is listed first, even though there are less zeros than ones in this case. And here, just as a side note, I want to mention that we could also use the sort parameter of this value counts method. So if we set that, I believe if we set that to false, if we set it to false, then we get the same result. So 0 is again listed in the first place. However, I think using the sort index method here makes it more clear what the code actually does. So let's use that. Let's run this again. And now let's again just look at all the passengers and not just the female passengers. So let's delete this here. So now that's the thing that I want to point out about this very counts method. So now let's store these counts and the names here into our table as the class names and class counts. Therefore, let's first store this panda series here into a variable called counts. And then let's also print that out again. And now the way that we can access these names here is with the index attribute. So we can say counts.index. This way we get the 0 and the 1. And those actual counts we can get by saying counts.values. So this way then we get the actual counts. So and now let's store these two lists here into our table under class names and class counts. So we're going to say table brackets class names. This equals counts dot index, and then table class counts equals counts dot values. So let's run this, and now let's have a look at the table. And now here we have our two entries. And here I want to point out one thing, namely this here, this for the class names, we have this index object, and we could actually use it, so it's not a problem, but I want to transform that also into a numpy array, like we have here for the class counts. Therefore, we can simply use the toNumpy method on this index attribute here. So we're going to say toNumpy, and if you now look at our table, now we have two numpy arrays here. Okay, so that's already everything we have to do with respect to the label. So now let's write another comment. So now let's determine the probabilities for the features. Okay, so what I want to do is for each feature we want to know for each value these specific probabilities. So the first thing that we need to do then here is to loop, or we need to access all the features. So we need to loop over all the features of our data frame, and we can get those by saying df.columns. So this now is a list-like object where we have all the column names, and obviously here we still have the label, so we need to drop that. So we're going to say df drop label column in axis 1. So if you run this like that, then we don't have the survived column anymore. Now we can loop over this list-like object here. So we're going to say for feature in df.columns, and now so that we don't have to actually use print statements all the time, let's write here a comment, and let's just keep writing the code in the next cell. And so that we then actually have something to work with, let's create a variable called feature, and the feature that we're going to look at is, or that we're going to use, is 6. So we're going to pretend here that in this cell we are currently looking at the iteration where we're looking at feature 6. Okay, so then let me just open a new view for this notebook. So what we do then, so this is in the same notebook, just another view. So let's again look at this example table. So now for each feature, what we want to do is we want to create such a dictionary. So the first thing that we're going to do in this for loop here is to create an empty dictionary that we then can populate. So we're going to say table brackets feature, and this equals again an empty dictionary. So let's run this, and now if you look at the table, now we have for feature 6 we have an empty dictionary, and in that dictionary now what we want to do is for each feature we want to get those probabilities. So if you look again at our table here, what we want to know is for the feature how the values are distributed, and we just don't know, or we're not just going to want to know that for the whole data set, but we want to know how those values are distributed for each class here. So now what we want to do, or therefore then we can again use this value counts method. So to know how those values are distributed. So therefore obviously we first need to access the respective column. So we're going to say df brackets feature. So this way then we get this column where we have male and female values, and on that column we simply now use the value counts method again. So we're going to say value counts, and then let's run this, and here you can see that there are 577 male and 314 female. However, we obviously don't, as I just said, want to know that for the whole data set, but we want to know that for each respective class or label. So we need to group our data frame first by the label column. So we're going to say df dot group by, and then label column. So if we run this now, then now we have those counts for each respective class. So for the non-survivors we have 81 female and 468 male, and for the survivors 233 and 109. So 233 and 109. But obviously we don't just want to have those counts, but we actually want the probabilities here. And to get those we could use the normalized parameter of this value counts method. So if you set that to true, then we actually get the probabilities. So here for the non-survivors we have then 85 and 15. So 15 for the females, so 15, and male 85, so that's 85. And here then we have 68 and 32, so 68 and 32. However, we're not going to use this normalized parameter, and later on we will see then why. So instead what we will do is we're going to calculate those probabilities manually. So therefore let's again put this series here into a variable called counts. So let's print this out again. So those are the counts, and now to make the calculation of the probabilities a little bit easier, we're going to transform this series into a data frame, and therefore we're going to use the unstack method. And you can easily remember that because this starts with a u, and u means then to bring something up, and what we want to bring up is the label column. So if I say then here label column, then we have the same information just as a data frame. So let's put this into a variable called df counts, and then let's print out the counts again. So now we want to use those counts to calculate the probabilities, and therefore we need to know how many non-survivors there are in total and how many survivors. And that we can get simply by saying df counts.sum. So this gives us the sum for each column. So we have here 549 and 342. And now to calculate the probabilities, we simply have to divide these numbers here by the respective total sum. So for example, 81 by 549 and 468 by 549. And then the same thing for this column. And that we can do by simply saying df counts divided by df counts dot sum. So this way then we get again the probabilities that we have here on the table. So we have here for the non-survivors we have 15 and 85, so 15 and 85, and for the survivors 68 and 42, so 68 and 42. So let's store this in a variable called df probabilities. Let's print those out. So now we have the probabilities that we want, and now let's store them into this empty dictionary. And therefore let's see what we actually want to store from this data frame here, namely for a feature for the value female we want to store 15 and 68. So if you look here at our data frame, here we have female and we want to store 15 and 68%. So we actually want to store this row here, and for male then 85 and 32, so that's 85 and 32. So now to store those probabilities we need to loop over the index here, and that we can do by saying just df probabilities dot index. So this gives us then a list with the values. So over that we can loop, so we can say for value in df probabilities dot index, and here again let's write the code that's going to be going that will go into this for loop in the next cell. And therefore again let's create a variable called value, and this we will just pick a female. So we pretend that we are currently looking at the value female in this for loop here. And let me again print out the probabilities. So now we want to access this row here, and that we can do by saying df probabilities.log and then brackets and then our value. So if you run this now, then we have here this row, so 15 and 68, so 15 and 68. And this row now we want to store in this empty dictionary under the value female, so that we then get this entry here. Okay, so therefore let's store these probabilities in a variable called probabilities, and let's print them out again. Probabilities, and again, since we actually want to have here numpy arrays, we're going to transform that into a numpy array. So we say to numpy. So let's run this again. So then we have again a numpy array with the probabilities, and those we now want to store under the value female in our table. So we're going to say table brackets feature. This way we access this empty dictionary here, and then we create a new entry, and namely we want that entry for the value, and what we want to put in there are the probabilities. So let's run this now, and now let's have a look at the table. And here now you can see we have this entry for the feature sex, we have female, and then we have here these probabilities 15 and 68. Okay, so that's the code for our function. So now let's put everything together. So let's put this into this for loop. Let's put all of this into this for loop, and that's now our whole function for this create table. So let's run this for all the features, and now let's print out the table. So here now we have all of our probabilities. So now we are basically done with the code for our create table function. So we could copy this code into the table. However, before we do that, we have to address one problem. Namely, as you can see here, for example, for the feature parents and children, we have here these two nans. So NaN stands for not a number. So this is not a number. So what we now need to do is we need to replace those nans with actual probabilities. Otherwise we will run into some errors. So therefore, let's first check why these nans here actually appear, and then how we solve that. And actually here now in the last iteration of this for loop, we were currently actually looking at the feature parents and children. So everything that we've done here in this for loop is related to the feature parents and children. So let's look at this counts variable here. So if we print that out, then here we can see that for the non-survivors, we have examples for each value that we have for the parents and children. So here we have 0, 1, 2, 3, 4, 5, and 6. And for the survivors, we have the problem that there we don't have entries for value 4, and so there's no 4 here, and then value 6. So there's also no value 6. That's exactly where the problem is. Namely, that is the problem of rare values, which I have covered in the second video of my Naive Bayes Explained series. So if you want to know more about that, then you can check out that video. I will put the link to that into the description. So then, so here's the code for our function. So then what happens here in the next step, we create this, out of this series, we create a pandas data frame. And what then happens is, since there are no values for the survivors, pandas simply replaces those empty or those missing values with nans. So this is where the nans in our table here come from. So now we need to replace those with probabilities. And the way that we do that, we have also already covered in the Naive Bayes Explained video. Namely, what we do, we simply add one entry to each, one value or one count to each entry in this data frame here. So that's what we want to do now. And obviously, we only want to do that if there actually are any nans in this data frame. So now let's write an if statement and that checks exactly for that. Okay, so let's. In that if statement, then we're gonna put here after we've created the f counts. So we can here say comment and then say check for, let's call this check for problem of rare values. So we want to check if there are any nans in this data frame here. Therefore, we can say dfcounts.isNA. And you could also use isNull. And this then returns a data frame with booleans. And when there is a nan, it will say that there is, we will then have true values. So now, obviously, we don't just want to have a data frame with booleans, but we just want to know if there are any true values in this data frame. And therefore, we can use the method any, simply any. So if you run this now, then this checks if there are any true values for each column. So since there are no true values in column 0, here we have a false, but in column 1 there were these nans. That's why it says true. But obviously we just want to know if there are any true values in the whole data frame. So that's why we set the access parameter equal to none. So this then returns a true. So this is then our if statement. So if this if statement is true, then we have to deal with the problem of rare values here in our function. So, and now let's see how we do that. Namely, we want to add one entry here to one count to each entry here. However, if we just say, for example, df counts plus 1, then we add one entry to each number here. So here we had 445 and here we have 446. However, the nans are still nans. So we first need to replace them and only then add a 1. So we're going to replace them with a 0 and then add the 1. So to replace those nans, we can use the fill NA method, and the value that we want to replace them with is 0. So if we run this, then now these nans are here 0. However, just running the code like this doesn't really change this df counts variable. So if I run this this cell here again, we actually still have these nans. So that we actually change now this df counts variable, we need to use the in place parameter and set that to true. So now if I run this cell here again, now we have actually here a 0. Now we simply add one count to each entry. So we're going to say df counts plus equals 1. And if we run this now and then have a look again at df counts, then now here we have actually a count of 1 instead of 0, and all the others also have increased by 1. So this is what we're going to do when we have the problem of rare values. So now this is what the new code looks like. So let's run this now again, and now let's look at the table, and now you can see we don't have these nans anymore. So this is what the code now looks like. So let's cut this here and put it into our function, or create table function. So let's run this cell again, and now let's actually use this function to create our this lookup table here. So we're going to say lookup table equals create table, and we put in our data frame, training data, and then the label column is survived, and then let's print out, print the lookup table. So this is our table here, and with that now we have finished the first step of the algorithm. So now let's create then the function that is going to do the second step here of the algorithm. So let's create another heading for that. So there we say simply second step of the algorithm. And the code for that we're gonna build in the next video. So thanks for watching, and hopefully I will see you in the next video.